ABA, you construct it using this alphabet here. And you use 3 symbols here. Therefore, the length is what is 3. So absolute value of a word means what? The length of that word here. And the length is the number of symbols you have used to create that word. Any questions? Okay.
Yes.
Yes, ma'am.
Will you recall the meeting? Will you recall the lecture?
Oh, last thing. Okay. The length of a word, the length
No,
of a
I'm
word.
sorry, Professor. Will you recall the lecture?
No, I didn't. No, I don't. No, I
Professor,
don't.
I have
No,
a
no.
question, Professor.
Yes.
So
What
in
is it?
this in the second example, the length is 2, right?
Uh-huh.
So we are considering A, comma BA, and when you group it as a word, it is ABA.
Yes.
So A is one length and BA is the other length.
And is another one, right?
So
See?
what if my perception is AB? What if my perception is AB as 1 and A as 1?
Okay, no, that is the first. See, if you're sigma, if you're okay, if your sigma is A and B, I have 2 symbols, right?
Mhm.
Okay, if I have a word AA, what is the length of this one here? I'm using what?
It's
A
2.
twice, so 2.
2.
If I create word AB, then one symbol is what is A, the other symbol is what is B, so the length of this one here is what is 2, right?
Yeah.
Okay. If my alphabet changed to this one here, for example, A and then BB, A and BB, right? So one symbol is this, and one symbol is what is this one here. Think of this one here as apple, and think of this one here as what as banana here. So if I have A and then BB, how many symbols I have here? I have one apple, and I have what? One banana here. So the length of this one here is what is 2, based on this alphabet.
So when we are grouping it into a one word, we have to take the valid symbols.
Yes.
Then only we can tell the
See,
correct. Yeah.
yeah, when you group them, you can group them any way you want it. For example, if I have BBA, then what? The length of this one here is what is 2. But what happened if I have BAB?
Yes, that is what I mean to say.
Okay, is this one, okay, B, see, 1B, I don't have it here. 1B, I don't have it here. I have 1A here. So this word is not formed by this alphabet here.
Okay. So we have to take the valid ones. Okay.
Right, right.
Yeah.
So a valid word is the length of it. That's a good one. The length of a valid word is the number of symbols you have used to create it.
Yes. Thank
Okay.
you.
Now, a word of length 0. A word of length 0 is called a null word. And this word, we are using the Greek letter lambda. The Greek letter lambda. See, one book is using what is using epsilon, the other book is what is using lambda here. So I decided what? I decided to use lambda because this one here is what we use for a member of. Okay, that is one place you can see what those 2 books are not using the same notation here. So from now on, every time you see lambda, it is what? It is a word of length 0. So the length of this is what is 0. And then at this point, you want to say, okay, what do you mean? We don't have any word of length 0. You are right until what I give you example, then you can see how important lambda is. Okay, if lambda is part of any word, for example, I have sigma is what is A and B. And I have a word A, lambda, B, and then what is the length of this one here? Is 1, and then 2. The length of lambda is what is 0. So this one here is what is the word of length 2. For that reason, if lambda is part of any word, you can ignore it. So this is what, this is just A, what A, B here. If lambda is part of any word, you can what? You can ignore them all. It is called what? A null word here. Okay, the next thing is, okay, let me clean up these things here. What is the power of a word? If W is a word, then W to 0 power in algebra, what is a number to 0 power? Any number to 0 power is what is 1. But here we are talking about strings. Any string or any word to 0 power is what is lambda. And then a word to second power is what is concatenation of that word to itself. A word to third power is combination of the word, concatenation of that word to itself 3 times. So the power is what is the number of times you concatenate that word to itself. So if I have a word, for example, AB, what is W squared? It is AB, and then what? AB here. This is not A squared, B squared. This is not algebra. Why not A squared, B squared? Because A squared is what? A concatenated to itself twice is AA. And then B concatenated to itself twice is BB. Now, AB is not this one here. This word starts at A, and then what? The next letter is what is B. This word starts at A, the next letter is what is A. So this word and this word here are not the same. Therefore, the word AB is not the same as the word BA here. This word starts with A, this word what starts with B here. So the order of the symbols are what are important here. Okay, the order of the a string of symbols is what is important here. Remember, AB is not the same as BA here. This is a word, it starts with A. This is a word, it starts with what? With B. So these two words are not the same. Got it? So if I have AB to second power is not algebra A squared, B squared. This is a word concatenated to itself twice. So it is AB and then what? AB. And that's it. Don't try to simplify this one here and write it as A squared, B squared, because this is not correct. Any questions? Okay, now we talk about factoring. If I have a word AB, and if I have a word, for example, AC, okay, this word and this word here, both of them starts at what? At A. So I can factor by A here. If I factor by A, from this one here, we have B, or from this one here, we have what? We have C. So when you have something like this one here in algebra, you multiply. In here, what? You do the concatenation. A concatenated with B, which is A followed by B, and then A concatenated with C is what is AC. I get exactly the same as this one here. Now, what happens if I have this one here, AB, or what? Or A. Okay, this one has A, this one has A. I can factor by A. What is left from this one here? B. What is left from this one here?
It's
Is
1.
it lambda?
Lambda.
Lambda.
Lambda, very good. See, I have to have something here. So now if I do concatenation, A concatenated with B, I get AB, or A concatenated with lambda is A lambda, which is the same as what AB, or I can ignore lambda here, I get A, which is exactly the same as what I have here. Okay, so this is called left factoring. If I have something like this one here, BA and then CA. Okay, this word and this word here, they have A in common on the right-hand side. So I factor by what? By A on the right-hand side. What is left from this one here, B, and what is left from this one here, C. If you want to check your work, okay, B followed by A is BA, or concatenated with A is A, and the C concatenated with A is what is CA. I get what? Exactly the same thing. This is called right factoring. This is called right factoring. Okay, now if I have, for example, A, B, C, and I have if I have A, B, C, and if I have A, D, C. Okay, these two words, they have A in common on the left-hand side. So if I factor by A, this one here is B, C, and this one here is what is D, C here. Now what? Inside the parentheses, these two words, they have C in common on the right-hand side. So if I factor by C on the right-hand side, I have B here, and then what? B here. So these are the words, they have something in common on the left-hand side, they have something in common on the right-hand side. So you can do left factoring, you can do what? The right factoring here. Check your work. Okay, A concatenated with B is AB, A concatenated with D is what is AD. The whole thing concatenated with what? With C. This one here, A, B, C, and this one here, A, D, and what? And C here. I get back to what? To my original. Okay, so we have left factoring, we have right factoring, we have combination of those two as well. It depends on what the words you are looking at. Okay.
Professor?
Yes, ma'am.
I have one question. What if the letter is available, is there in the middle of the word? Can we do factoring for that? Or is it?
Okay, no. See, if I have, for example, A, B, C, and I have, for example, D, B, and then what? And then E. See, they have this one here in common in the middle, but I cannot pull it out.
So they remain as is.
So this one here, yeah, they have something in common in the middle, but I cannot pull that middle part out here.
Okay.
So this one here, you cannot factor.
Okay, got it.
Is that the same, Professor, for if you have, like, say you have A, B, and BA, they share characters, but one's on the left and one's on the right?
Say it again, please. AC?
A, B, and BA, or we'll make it A, B, and C.
Yeah, this one, yeah, you're right. See, this one has A on the left-hand side. This one here doesn't have A on the left-hand side. I cannot factor. This one has B on the right-hand side. This one doesn't have B on the right. I cannot simplify this one here because this one and this one here are what are two different words. This starts with A, this one here starts with B. This ends in B, this one here ends in what? Ends in A here. They don't have anything in common on the left-hand side. They don't have anything common on the right-hand side. Okay?
Thank you.
You're very welcome. Okay, now, okay, we are getting to good parts here. Given sigma, Means what? Give me any alphabet you want. Okay. The set of all words over sigma, including lambda, is called sigma star. Give me an alphabet. The set of all words, including lambda, over that alphabet, it is called sigma star. So if sigma if sigma is A and B, what is sigma star? The set of all words which are combination of what? Of A and B, including what? Lambda. So as soon as you want to write sigma star, the first word is what? Is lambda. I don't want to miss any word, so we list the words based on their length. So this is a word of length 0. How many words of length 1 we have? Either A or what? Or B. Okay, so this is word of length 0. These are all words of length 1. How many words of length 2 we have? Okay, one is what? One is AA, right? The other one is what? Is AB. The other one is what? Is BB. Is that all?
BA.
You mean no? Why not? One is missing. One word of length 2 is missing. What
BA.
is it?
BA.
What is it?
BA.
Very good. See, this is the time you see the difference between what we are talking about here and algebra. The word AB and the word BA both are length 2, but they are not the same words. So these are all words of length, what? Length 2. Okay, how do you find all words of length 3? Okay, we go back to what? Back to discrete mathematics. Okay, I'm looking for all words of length 3 using A and B. So this is how you do it. Either the first letter is A or the first letter is what? Is B. If the first letter is A, the second one is either A or what? Or B. If the first letter is B, the second one is either A or what? Or B. Okay, now what? If the first one is A, the second one is A, what is the last one? Either A or B. If the first one is A, the second one is B, the third one is A or B, this one here A or B, and this one here A, what? A or B here. So how many words of length 3 we have? 1, 2, 3, 4, 5, 6, 7, and then what? 8 here. Okay, how do you know 8? Back to discrete mathematics. I have 3, I am looking for words of length 3. In how many times I can fill this box here? Either A or B, so 2 times. In how many times I can fill this box here? Either A or B, so 2 times. And then for the last letter, for the last part, either I can use A or what? Or B. So 2 times 2 times 2 is what? Is 8. And that is what? That is the number of words of length 3 we have here. So how many words of length 4 we can have? Okay, the first position, either A or B. The second position, A or B. The third position, A or B. The last position, A what? A or B here. So we have what? We have 16 words of length 4. Okay, how do you write them down? Exactly the same. This is the first position. This is the second one. This is the third one. And then this one here is what? Is the last one here. So altogether, you are going to end up with what? With 16 words of length 4. Okay, now I did it here step by step. So the alphabet is A and B. Because we don't want to miss any word, we list them by their length. So word of length 0 is lambda. Words of length 1 is A or B. Words of length 2 is what is this one here, words of length 3 is this one here, and what, and so on. So every time you have the sigma and you want to find the sigma star, make sure what, to list the words based on what, their length. And that guarantees what, you're not going to miss any word here. Okay, so after you did this, think of this example as what you started with English alphabets, and you come up with what, with a lot of words of length 1, length 2, length 3, length 4, and so on here. One of the words of length 2 is what, is AB. One of the words of length 2 is AB. What does it mean? Nothing. But if the word is what, is IF, then what? It has a meaning here in English. So this is a word what in English. If the word is what, is DO, yes, it is a word in English here. If the word is what, is go, length 2 is go, then this is what, this is a word in English here. So if I start with an alphabet and I find sigma star, then any subset of sigma star is called a language. So all words, and now if I collect only English words here, then the language is what is called English. If I find all words, all Spanish words, and collect them all, it is called what? Spanish language, German language, and so on. So after you did this one here, the first language I'm interested is what is all powers of A, including 0 power. So lambda, A squared, A cubed, and so on. I have A to 0 power, A to first power, A to second power, A to third power here. If you have something like this, we have a special name for this language here. And the name is what is A star. So what is A star? Is a language whose words are A to 0 power, A to first power, A to second power, and so on here. Okay, so now if I use this, is AA a word in the language A star? Is AA a word in this language? AA is what is this one here? Yes, the answer is true.
Yes, it is.
Got it?
Yeah.
So if we collect, for example, all words of length 2 in English, is go a word, an English word? Yes, it is in the language. Is do a word in the language? Yes. So exactly the same as this one here. AA is a word in this language. Got it? So what is A star? A star is a language consisting of what? All powers of A, including the 0 power. Okay, including the 0 power. Now, what happens if I have only powers of A, A3, and so on? I don't have lambda. Okay, who is this guy here? Let's see if we can find a name for this one here. This is equal to, let me write it here. The language is A squared, A cubed, and so on. Okay, this is what? All these words, they have A in common on the left-hand side. So I can factor by A. If I factor by A, what is the first one?
Lambda.
Very good, very good. Lambda. A squared gives you what? Gives you A cubed gives you what? A to second power, and so on. So this one here is what is A. What is this language? It is A.
Sigma.
So this one here, if you simplify, it is what? It is A star. At the same time, what happened if I factor this one here by A on the right-hand side? If I factor by A on the right-hand side, what do I get? I get lambda, I get A squared, and so on. And what is this one here? It is A star, and then what? A here. So what is the conclusion? the language A star is the same as what? Is the same as A star, and then what? A here. So these are what? These are the same as identities. You prove what in algebra here. They don't look the same, but they have the same value here. Got it? Okay, we have a name for this one here because a lot of times you come up with something like this. This one here is called A plus. So A plus is all powers of A except the 0 power. What is A star is all powers of A including 0 power. Got it? So A star is all powers of A including the 0 power. And what is A plus? Is all powers of A excluding 0 power, A1, A2, and so on here. That's the difference between A star and A plus. Okay? And I went through more examples here. Suppose the language is what is this one here. Can you simplify this language? Okay, let's see. Lambda, so okay, is the same as what? AB to 0 power. This is what? AB to first power. AB is what? Is AB to second power. So what I have is what? Is all powers of AB, including what? The 0 power. So what is a good name for this language? Is AB star here. So AB star is what? All powers of AB, including what? 0 power. So AB to 0 power, and then AB to first power, and then AB to second power, and so on. Now, if they ask you this question here, is AB a word in language, AB star?
True.
Yes, true, I have it here. See, AB to second power is AB. So still, there are some graduate schools. They ask you to take GRE subject exam. GRE subject exam here means what? All the questions are related to computer science. More than 27% of the questions in that exam comes from this course, because there are a lot of challenging questions you can ask. And that's why majority of the questions in GRE subject exam comes from this course. Okay, so if you want to go to good graduate school, then there is a big possibility to ask you take the GRE subject exam. Okay, now look at, okay, we did this one here. I have two set of words, A star, and then B, or, and then A star, and then what? A here. Can I simplify this? This is a language. It has two set of words. One set of words are this, another set of words is what is this one here. So this plus act like what? Union. So who are the words in this language? All these words, union with what? With all these words here. Can you simplify this one here? Yes, they have A star in common on the left-hand side. So I factor by A star. From this one here, the leftover is B. From this one here, the leftover is what? Is A here. Got it? So you can, that is another application of factoring. You have a language like this one here. Can you simplify this one more? Yes, they have A star in common. If I factor by A star, I get this. So this is the simple form of what? Of something like this one here. Okay, for example, what is what is L equal to A or A star. Okay, this one here means what? Means the union of these two. So this set, you have A union. What do you have in this one here? You have lambda, you have A squared, and so on. Back to discrete math. What is the union of these two? I have A here, I have A here. So this A is not going to add anything more to this one here. I have A lambda, and then A, and then A squared, and so on. So the union is what is just A star here. So this one here already have A. If I add one more A here, I don't get two A's here because it is union. Okay, so what is A star or A star? Is this add anything more to this set? No. Is this add anything more to this set? No. Therefore, the result is what is A star.
A star.
Okay, so that's why I said a lot of theory at the beginning here, because these are the things we are using what from discrete mathematics here, and there are more things like this one here in this course. Okay, now let's go down here. This is the
Excuse
challenging
me,
part.
Professor.
Yes, ma'am.
Could you please explain one more time?
Oh, say it one more
So L
time.
means
Sure.
union.
Okay, hold on. Okay, look at this. Look at this. If I have A star or A star, this is what? This is the union of two language. So what is this one here? Lambda, A squared, and so on. Union with A star is lambda, A squared, and so on. What is the union of these two set here? Everything here is here. Everything here is here. Therefore, their union is lambda, A squared, and so on, which is what? A star. So this set of words are not adding more words to this. This set of words are not adding more things to what to this one here. Therefore, their union is what is the same.
Okay, thank you.
Got it? No problem. Okay, now these are the challenging problems, and you're gonna have fun. Okay, true or false? Is A cube, the first one, is A cube a member of A star?
Yes.
Okay, right now you can see it. If you cannot see it immediately here, expand this one here. What is A star? A star is
Lambda.
A to the second power, A to third power, and so on. So this guy here is what is here. Therefore, this is what? True. Okay. If you can, after a few problems, then you can what? Look and say, okay, it is true. Okay, is this one here is
So,
A
I
squared?
have one question.
Yes, ma'am.
What if we do A plus union A star? Does that become A star?
Is A plus union A star?
Yeah.
Okay, what do I get? You give me the answer. See, is this one add anything to this? No. Is this add anything to this one here? Yes. Lambda. So altogether we have what? We have A star.
A star. Okay. Got it.
Okay.
Thank you.
Now this one here is A squared B, a member of A star, and then B star. Okay, look and see how you can answer this question here. Ready? I can hear you.
Yes.
Okay. See, this word has what? Has two parts. This part,
A.
okay, this part, oh no. This part and then this part here. Okay, this part comes from here. Is it true or false? True. This one here comes what? Comes from this part here. 1b is here, 2a's are what are here. Therefore, this one here is what is true. Okay, now, if it is not clear, look at this one here. A squared b is a member of A star, and then what? B star. Okay, what is A star and then B star? Is lambda A and then lambda powers of what? Powers of B. Okay, when you concatenate this to here, make sure what to concatenate them and list the words based on what? Their length. Yes? Okay, lambda and lambda, I get what? I get lambda. How many words of length 1 we get here? 1a or what? Or 1b? How many words of length 2 we get? Is what? Is AA, right? Only from this one here. It is BB. Any more words of length 2?
Yes, AB
AB, very good.
and BA.
BA.
1A from this one here, 1B from this one. Is BA here?
I don't think BA should be there.
Huh?
BA should not be there.
Yeah, is BA here? No,
No.
BA, yeah,
Oh.
B, see, if I have a B, means what? From this one, I don't choose anything. That is lambda. And if I get B, I cannot have any more A after B here. So this is not in A star and then B star. Okay, but this is what? This is a word of length 3. So if I keep continue, is AAB here? Yes, therefore this one here is what is true. Okay, so maybe at the beginning you want to do the expansion here to find exactly this word in the result, or you can say what? A squared, I can get it what from this. 1b, I can get it from this one here, therefore we are fine. Okay, the next one is B cubed is a member of A star and then B star. Okay, I don't need any A. So what do you choose from this one here?
Lambda.
I need what? 3 B's. Can I get 3 B's from this one here? Sure. And this is what? This is B cubed, therefore this is true. Got it? Okay, what is this one here?
That's true.
A squared. B is a member of A star or B star. Okay, see, look at the right hand side. Powers of A or powers of B. So I don't get any union of these words, union of what with union of this language. So either all powers of A and all powers of B are what are collected here. But who is this guy here? Is not just powers of A, powers of B. It is combination of A and B. So I am not going to find this one what in this group here. Because if I need A squared, I can get it here. But the B comes from this group. I cannot get this one here. See, powers of A union with powers of B. So what do I have in my collection? Lambda, 1A or 1B, and then 2 A's or what? Or 2 B's, 3 A's or what? Or 3 B's here, and so on. Is this one here? No. Therefore, this is not true.
So, Professor, anytime we
Yes.
see a plus, it means or. We are
Or,
dealing or.
it is union.
Right.
It is union. So see, all of these words union with all of these words. So lambda is in both of them. And then I have A here, I have 1B here. So these are the only words of length 1. Length 2, A squared from here, B squared from this one here, A squared, B squared. All words of length 3, A cubed from here, B cubed from here. Okay? Now, the last one is A squared and B cubed. And then A squared is a word in A star. B star, and then what? A star. Okay, A squared, I can get it what from this one here, right? B cubed, I can get it from this one here, and then A squared, I can get it what from this one here. Therefore, it is true. How about this? Is A squared is a member of A star, B star, and then A star. Is this true? A
Yes.
squared,
Yes.
I can get it from
It
here.
is true.
Do
It
we
is
need
equal.
anything from this one here? No.
Lambda.
Do we need anything from this one here? No lambda. Okay, is A, B, B, a word in A star, B star, and then A star. Okay, A, I get it from here.
No.
B, I can get it from here. And I don't need any more A here. So this is what? Lambda. True.
Oh yeah, my bad.
Is BA a word in A star, B star?
No. False.
Yes or no?
No,
No.
it is
No.
not. No, it is not.
No.
Very good. See, I need a B. I get B from here. So this is lambda, I get B here. And then what? Is there any A after B? No. So this is not true. Okay, now this is the fun part. Okay, who is this language here? A. A or B star. Okay, I expand this one here to see what I come up with. Okay, this is what? A or B to 0 power C star, right? A or B to first power, and then A or B to second power, and so on. Correct?
Yes.
Okay, perfect. This is equal to A or B to 0 power is lambda. A or B to first power is either A or what or B. What is AB to second power? AB to second power means what? Concatenate this parenthesis to itself twice. Correct?
Yes.
Yes, perfect. Okay, now do the concatenation. AA, so AA, and then what? AB, and then BA, and
BP.
BB.
So I have all words of length 1. I have all words of length 2. I'm going to have all words of what? Words of length 3 here. Okay, means what? I have all powers of A. I have all powers of B, and I have all combination of A's and B's. So this is what this is the largest language we created so far here. This combination is a language whose words are powers of A, powers of A, and then A squared, and then A cubed, and so on. Powers of B means B here, and then B squared here, B cubed here, and so on. And also what? All the combination of A's and B's. So any word A, B, B, A, is this a word in A, B star? The answer is yes. It is a word of length 4. And if I find AB to 4th power, one of the word is what is going to be this one here. So A or B star is what is a language consists of lambda, all powers of A, all powers of B, and all what? Combination of A's and B's. all combination of A's. This is one combination of A's and B's. In the other word, any word which is formed by A's and B's, it is a word in this language here. Okay, and that I went through the whole thing to show you what I'm talking about. So this one here, if you explain it in English, is all powers of A, all powers of B, and all combinations of A's and B's.
And Professor, what is the highest number of powers we can have?
Oh, you can have as in, the highest power of what?
The language,
Oh, the language.
like the
See,
stand.
no. See the language here. You write the first few words, and then you see the pattern, and that's what the dot is. When you see the pattern, is follow this dot here. So I have a squared, a cubed. What is the next one? A4,
power
A5,
4.
and so on. I have b squared, b cubed, and then what's the next one? Dot, b. So all powers of b. And then I have a, b, and then ba. And then what? Means what? Words of length 2, words of length 3, words of length 4, which is one of them is what is this one here. See, you see the pattern, and then put dot, means what? Follow that pattern. What is the set of integer numbers? 1, 2, 3. So what is the next? See dot. Do I have to list them all? No, you can see the pattern. Okay, so if I have a squared, a cubed, what are the rest of the words here?
No, I mean to say the length can extend how much ever you want.
The length is what is how much you want.
Okay.
Okay,
Which
so
is the
now
position
these are good questions to ask here. Is a cube the word in this one here? Yes, any word, any power of a is what is the word in this one here. Is b5 a word in this one here? Yes. Is this word a member of this one here? Yes. Is all a's followed by what? Followed by b's. Is this one here a word? Is combination of a's, b's, and what? And a's again. It is a word in this one here. Okay, so any word, as long as it is powers of A only, powers of B only, or combination of A's and B's are in A or B star here. Okay, it is 8:31. I give you, sorry, I started the class late, but I don't want you to pay for it, but I need what? I need your generosity. Come back in 9 minutes. So it is 8:32. Please come back at 8:40. Okay, take a break for 8 minutes.
Professor, can I have a question?
What is it, ma'am?
Can I have a question?
You have a question to ask?
Yes.
Okay, come back after break. I answer your question.
Okay. Thank you.
Professor, for the fourth one, A star plus B star. For the fourth one, right here, uh, in the examples true or false. The fourth one,
1, 2, 3, 4. This one.
yeah, that one, that
Okay.
one. So
Okay, I talked
A
about
star,
it.
A
I
star.
talked about it.
I know, I know. I'm just asking you another question. A star plus B star is a subset of A star B star.
Yeah, A star. You see this one here, A star. The left hand side, you can have combination of words start with A and then followed by some B's.
Right. So,
But in the second one, on the right hand side, I get only what? Only powers of A or powers of B. I don't get any combination of A and B.
I see. So what I typed in the chat, is it right? I typed something in the chat. Can you check it?
Okay, I don't want to.
Okay, that's fine. That's fine.
Yeah, because I don't want to lose the control. Okay, let the other people come back. Okay, okay. So this is number. This one here, A star, B star. Is this the same as A star or B star? Okay, see, look at the right hand side. Powers of A or powers of B. So AB is what is on the left hand side. A here and then B here is on left hand side, right? But is AB on the right hand side? No, either I cannot have any combination of A's and B's here. So this is not on the right hand side. As soon as you find one word which is on the left hand side and not on the right hand side or vice versa, then what? And this one here is not true. But if I start from the other side, A is A star, B star, the same as A star or B star. For example, A5, I have it here. Do I have it here? I can get A5 here, and then this is what? Lambda. B10, B to 10 power is here. Can I get it here? Yes. This one here is lambda. I can get B to any power. So whatever you have here, it is here. But that doesn't mean what? These two are the same. If you remember, two sets are equal if A is a subset of B, means everything in A is in B. And B is what is a subset of A in discrete math. If everything in A is in B and everything in B is in A, then these two sets are what are the same. So that is what we have here. Everything here is here. So this is what everything here is what, so this is true. But is everything here also here? No. One word, AB is here, but is not here.
Okay, sounds good. Actually, I did get that question totally, but I was just trying to ask something else. But it's I got the answer. Thank you.
Okay, perfect. Perfect. Okay. The next one is we are getting close to relate everything I talk about tonight to what to C++. Maybe not. Maybe by next time, then everything I talk about I related what to C++. Okay. The next thing is what is finite automata. This is supposed to be by itself a course. If you still go to USC, they have a course on the finite automata here. But now, because we merged these two courses, so this one here is what is part of the Computer Science 323. But by the way, before I continue, I talked to the department this afternoon. A few students, they send me email, and they were concerning about adding the course. I talked to the department here. I don't mind how many students I have in the class, as long as there is a room in the class here. But because after 2 weeks, we're going to go back to normal, the size of the class, the CRG something, is only 32 students. We cannot have more than 32 students in the class. Right now, Sandra, the secretary, told me there are 3 people in the waiting list. So those 3 people in the waiting list, if someone drops, then she is gonna add those people to the class here. But at the same time, she said other sections are open. There are 4 other sections are open. So if you really want to have this course, don't take the risk. Please apply other sections. I'd love to have you, but because of the size of the class, there is a limitation here. If the class was all online, I don't care how many students I have in the class. But there's a big possibility we go back to normal after 2 weeks, and the class they assigned it to this course has a limitation of only 32 or 34 students. I don't remember, 32 or 34 students. So for that reason, please, if you really want to have this course, please make sure to check other sections as well. Okay, the finite automata is a machine with a finite number of states. It is a machine with finite number of states. Suppose we want to design a vending machine to accept 5 cents, 10 cents, and 25 cents. So the coin you can drop in the machine are only a dime, nickel, or quarter. And then if you want to get something back from the machine, the total money you drop in the machine has to be 10 cents, a total of 15 cents, or a total of 25 cents. If you drop more than enough, just to make the machine simple, you are not going to get anything back from the machine. So keep those in mind. This is how to construct that finite automata here. Let's start from here. This is the place you drop money, you drop coin. If I'll call it a state Q0. Okay, if you start here, if you drop the first 5 cents, it takes you what to state Q1, another 5 cents, another 5 cents, another 5 cents, another 5 cents. We end up what at this state here. And now because there are some items in the machine cost a total of 25 cents. If I drop 5555 and I stop here and I press a button, I can get that item what? Back from the machine here. Any state you can get something back from the machine is called a final state here. So initial state is where you drop the machine. The final state, when the amount of money you dropped is good enough to get something back from the machine here. So this is the story of all 5 cents here. Now, what happened at state Q0 if I drop 10 cents? If I drop 10 cents, I go from Q0 to what to Q2. What happened at state Q1? I drop 10 cents here. From Q1, I go to what to Q3. At the state Q2, if I drop 10 cents, I go to here. At the state Q3, if I drop 10 cents, I go to this state. What happened at the state Q4? I drop 10 cents. If I drop 10 cents here, I pass what? I pass the limit. I don't get anything from the machine, and I drop what? More than enough in the machine here. Okay, so we took care of all 5 cents. If you drop 5 after 5, we took care of combination of 10 and 5. If you drop 5 and then 10, and then 10, you get to here. The total is 25. You can get something back, what? Back from the machine here. Okay, so if I drop 10 and then 10 and then 10, you drop more than enough. You don't get anything back from the machine. But if you drop 10, 10, and then 5, you get what? You enter a final state, you get something back from the machine. The other thing is what I can get something back from the machine if the total coin is what is 15 cents. So 5 cents, 5 cents, 5 cents, I enter a final state. I get something from the machine. Or what? 5 cents and then 10 cents, I can get to here. Or 10 cents and 5 cents, I can what? I can get to here. Or if the total of money I drop is what is 10 cents here. So 5 and 5, I get to a final state. Or if I drop 1 dime, I get to here and I get something back from the machine here. Okay, the last coin we want to try is what is 25. At initial state, if I drop 25, I get what I get to here, and I can get something back from the machine here. So our machine is what is going to look like this. Our machine is going to look like this one here. Because the number of states are finite, that is called finite automata. Or a machine with a finite number of states. Okay, who are the states? Is the initial state, is the final state, final state, final state, and the states you don't get anything back from the machine. It is are called null states. N-U-L-L, null states here means they are states, but they don't get anything back to here. So there are 3 types of states in any finite automata. One is what? One is initial state. Some of them are final states, and the rest of them are what are null states here. So Q0 is initial, Q2, Q3, and Q5 are final states, and then Q1, nothing is going to happen. Q4, nothing is going to happen, are called null states here. Okay, so any finite automata consists of the following pieces: set of states Q0, Q1, Q2, Q3, Q4, Q5, in which only one initial state means there is only one place you can drop your coin. It is called initial state. So machine must have one initial state, and then what? One or more final states. So if there is only one final state, means what? You can get only one thing back from the machine. If there are 2 final states, there are 2 items in the machine. If there are 3 final states, there are 3 different items what in the machine here. And then what? So final, we have to have at least one final state here. If we don't have a final state, then you're wasting your money. No matter how much money you drop in the machine, you are not going to get anything back from the machine here. So that is not our dream, to construct a vending machine here. To make people happy, we want them to give a reward when the total money they drop is the same as what the cost of one of the items here. So at least one final, but more than one final is okay. You can go to a vending machine, they have 10 different items here. Okay, so you can get 10 items back if you want it. Or 0 or 1 null states here. Maybe what you don't have any null state, maybe what you have like this one here, 2 null states here. So a group of a finite number of states in which only 1 initial, 1 or more final, or 0 or more null states here. Machine has an alphabet. Machine has an alphabet. What is the alphabet? Alphabet of the machine is the amount of, is the coin you can drop in the machine here. Is the coin you can drop in the machine here. See, the machine doesn't accept a penny. So penny is what is not in the alphabet of the machine. What is in the alphabet of the machine? I can drop 5 cents, 10 cents, and 25 cents coin. Therefore, the alphabet of this machine are 5, 10, and 25 cents coin. Got it? So now we have what we have states, we have what we have alphabet here.
And
Okay,
Professor,
is,
there won't
yes.
be any feedback from final state to initial state?
No, we cannot go back. In the vending machine, can you go back? No, this machine here doesn't return any money here. So I cannot get my money back and start over. Okay, we just want to talk about the very simple vending machine here. So you cannot go back. And then what is the language of this machine here? The language of a machine is the sequence of coins take you from initial state to a final state. Take you from initial state to final state. So it is a language. If the amount of coins you drop in the machine take you what? To a final state. Means you can get what? Something back from the machine. Okay, the language of this machine is a sequence of coins. You can get something back from the machine here. Okay, now I want to list the words of the language of this machine here. What is the easiest way to do it? The easiest way to do it is what is when you list the coins by their length, by the number of coins here. So for example, number of coins, if I drop 1 coin, I can go what from initial to final here. And that coin is what is 25 cents.
Shouldn't
Right?
10 also be there?
Okay, no, okay. Let's get to 10. Okay. Oh, yeah, you're right. I forgot to put 10 here.
Because it's a final, yeah.
Thank you. So here, I 10 to, thank you. Okay, so these are all 1 coin I can drop in the machine and get something back. So 10 cents is what is a word in the language. 25 cents is a word what in the language of this machine here. And then what? Set of 2 coins. Then 5 and 5, 10 and 5, and then 5 and what? 5 and 10 here. Is 10 and 10 a word in the language of this machine? No, I don't get to final state here. Okay, and now look at this one here. The set of coins 10 and 5 are not the same as 5 and 10. They have the same value, but they are 2 sequence of coins. So this is what when we talk about AB is not the same as BA. In this machine, you can see it. 10 and 5 and 5 and 10 are 2 set of coins you can drop in the machine. to get something costs 15 cents here. And then what? 3 coins, and then 4 coins, and then at the end, what? 5 coins here. The only word of length 5 is what is 5, 5, 5, 5, 5, which is what? Which is this one here. So by doing this, you are able to list all words of length 1, length 2, length 3, length 4, and then what? Length 5, because the maximum is what is 5 coins you can drop in the machine here. For example, how do you find the words of length 3? How do you find the words of length 3 here? If you remember, I talked about it, and now let's see if you remember or not. The first coin is what is 5, is 10, or is what is 25. The second coin is what? If this is 5, it could be 5, it could be 10, it could be what? 25. This one here, it is 5, 10, 25, and this one here, 5, 10, and 25 here. So none of these words what is going to be a word in the language, because the amount of this one here is more than 25, amount of this is more than 25, amount of this one is more than 25 here. Okay, after this one here, 5, 10, and then what? 25 here. So one of the sequence of coins of length 3 is 5, 5, 5. We get what? We get to destination here. 5, 5, 10 is 5, 5, 10. Good. 5, 5, and then 10 brings you what? To here. So this is not good. 5, 5, 25. It is what? Is more than enough. That is not good. So the only word of 5 I can get from this group are 5, 5, and then what? 5 here. Is 5, 10, and 5 good? 5, 10, and 5. The total is what is 20. I end up here. That is not good. It is 5, 10, 10 is good. 5, 10, 10 is 25. I end up here. So this is good. This is good. So that's how you can find what? All the string of 3 coins you can drop in the machine and end up at a final state here.
I have one question, Professor.
Yes, sir.
So do you see where it says 5, 5, 10 and how that doesn't work?
Oh,
Would
5,
that
5, 10? Okay, see, look at this one.
Yeah,
here.
it wouldn't work
5,
because it's
no, look at this. 5, 5, and then 10. You end up
Yeah,
at Q4.
yeah. But you cross it out, but wouldn't it if we go 5, 5, 10 and then 5, it would go to Q5? So I'm wondering if after you cross it out, do you continue to expand it out?
Oh, 5, 5, 10. No, it's not good.
Yeah, but wouldn't 5, 5, 10, 5 work?
Yeah, I haven't got to that one yet. So this
Okay.
is a 5. Then I didn't write this one here. 5, and then 10, and then about 25 here. So 5, 10, 5, 5. That is good.
Okay.
That is good here because 5, 5, 5, and then 10. I end up at the final state here. I just did this one here to see where these things here are coming from here.
Okay.
Okay. Now, after you did this one here, there are 3 ways to show this machine. One is like this. One is like this one here, which is called okay. One way to construct the machine is to draw something like this one here. It is a diagram. Okay, a state diagram. This one here. But there are other ways to describe this machine, and those are the following here. It is called transition table. So instead of I show you this drawing, I can show you all those things using this table, which is called transition table. Write all the states Q0, Q1, Q2, Q3 up to Q5, Q0, 1, 2, 3, 4, 5 in horizontal and diagonal. Okay, a state Q0, if I drop 5 cents, I go to Q1. Q0, 5 cents, we go to Q1. See, I have that information here. A state Q0, if I drop 10, I go to Q2. A state Q0, if I drop 10, I go to Q2. A state Q0, if I drop 25, I go to what Q5 here, I have it here. So any information here, you can have them here too. You can have them here too. And then what? You have to specify who is initial state and who is what, and who are final states here. So Q0 is initial state, and then what? Q2, Q3, and then Q5 are final states here. So you have to write this information after your table. It is called transition table. So all the information you see here are what are summarized in this table here.
Professor, if you put 25 cents, 125 cents, it will take from initial to final, that is Q4. But
okay, no, see, from Q5, if I
no.
get to here, I cannot go anywhere.
No, I'm not talking about the transition table. I'm talking about the previous table, the number of coins. So if it is 125 cents, it will go from initial to final.
Yes.
But you need 2 10 cents to go to Q5. So the length of coins will be 2, right? So 10
Yes.
cannot be included there.
No.
It is
Okay.
just
You see
25.
this one here? Yeah, 10 and 5 are 2 coins. Those the length is 2.
No, but in the first column, the number of coins, it should be only 25. 10 shouldn't come there.
No, you see, if I drop 10 cents, see, this is from here to here. If I drop 10 cents, I end up at the final state. So 1 coin is enough to start from initial to go to final. One is what? One is 25, the other one is 10 cents.
Okay, so I was
Okay?
imagining Q5.
10 is what? Is a dime. Is one coin.
Sorry, my mistake. Thanks for clarifying, Professor.
Okay, yeah. Okay, the other thing is this one here. This is the one which is more important. It is called the grammar. It is called the grammar of this machine here. What is a grammar? The same set of information as well as this one here. From Q0, if we drop 5, we get to Q1. From Q0, if we drop 1, we get what? We get to Q1. At Q1, if I drop 5, I get what? I enter to state Q2. Or at Q1, if I drop 10 cents, I get what? I get to Q3 here. So all of this is summary of this one here, and they called grammar. They called grammar here. So this is what the same as the grammar of English. This is what the grammar of this machine. Machine has what? Alphabet, has what? Has language, and has what? Grammar here. Okay. And now, to understand this one here better, I go through few more examples here. If you name your states, lowercase letter, then the grammar of this one here is from Q0, drop 5 to enter Q1. We put the name of the state within angle brackets. We put the name of the states within angle brackets here. So this one here is lowercase name. This one here is lowercase name here. So when you write the grammar what has the name of the state has to be within angle brackets here. Now the same thing you can do what is here. If the name of a state is uppercase letter, then you don't need to use bracket here. So from a state A, if I drop 5 cents, I enter what? A state B. From a state Q0, if I drop 5 cents, I enter what? Q1. Because I name my states using lowercase letters, I have to enclose them within angle brackets here. Got it? So when you look at the first book or you look at the second book here, if you see this with angle bracket, for sure what? The name of the states are lowercase letters. If you don't see the angle brackets, the name of the states are what are uppercase letters here. So to write the grammar for the whole machine, start at Q0. If we drop 5, we go to Q1. Start at Q0. If we drop 10, we go to Q2, start at Q0. If we drop 25, we go over to Q5 here. So this is all grammars if we start at Q0. Then do the same thing. Start at Q1. If we drop 5 cents, we go to Q2. Q1, if we drop 10 cents, we go to Q3. Q1, if I drop 25, I pass the limit. So it is not part of the grammar. It is not part of the grammar here. So all together, we have them what we have them here. Q0, drop 5, go to Q1. Q0, drop 10, go to Q2. Q1, if you drop 5, you go to Q2, and so on. Now, how do you indicate the final states in the grammar? See, if it is a transition table, I have to write it here. Q2 is final state, Q4, 5 is final state, and so on. How do you bring those information to your grammar? Okay, see, at Q2, I can get something back from the machine because it is final state. So at Q2, I can stop. And I write it like this one here. Q2 is in form of lambda. Means Q2 is what is final state. Q3, I can stop. So Q3 is final state. And then Q5 is what I can stop, means Q5 is final state here. So in a grammar, if from a state you go to lambda without dropping any coin, that state is what is a final state here. That state is final state here. Kavita, any question, ma'am?
Professor, the sequence matters a lot, right? While you're converting the transition to the grammars.
Okay, yeah, this one here, the transition. The
sequence.
Here I have to write here who are the final states. In this one here, I don't have to do it. When you write all the grammars, and then what? Add this type of grammars here. Any grammar which ends up at lambda on the right-hand side means that state is final state.
So I mean to say that if I write Q2.
No, you don't write it. No, just okay, no, you don't have to write anything here. Just Q2 is in form of lambda. That's it.
So if I put this, if I put the
by default,
grammar.
Yeah, that state is a final state.
No, if I just change the sequence after Q2, Q1, go to Q3. If I just add
that's fine. Any order, the order is not important.
Okay, thank you.
The order is not important here because the collection of the grammar is representing what? Representing this one here. You can have them in any order you want. You can have all finalists at the end. You can have all finalists in front. Doesn't matter.
Yeah, thank you.
The order is not important. Okay.
Professor, I have a question. So why do we use lambda? Why are we using lambda? Lambda used to be the initial state. It used to represent.
This is just a notation for the grammars.
Okay.
It is a notation for grammar here. We use it to indicate that this state is a final state. Okay, and then one more thing. The first grammar, whatever it is, this one here is what is initial state. So we always have to start at initial state. The first grammar is always a start at initial state here. See here, I don't say anything about who is initial state. Q0 is what is initial state because it is the first grammar. It is the first grammar. Okay, now the difference between these two books. If you have initial state, one book is what is using this symbol. The other book is what is using this symbol here, a circle with a minus in the middle. One book is using this, the other book is using this one here. If it is a final state, one book is what? Oh, see this one here, it's a, I don't know why it doesn't show it, because it is very hard to draw it. Okay, it is this one here. Okay, so this one here is supposed to be this. So one book is using this notation, the other one is what is using this one here. A circle with a plus means that a state is a final state. Okay, so one book is using this, the other book is what is using this one here. The boy, okay, if it is initial and final. If it is initial and final, that's supposed to be like this one here. 2 circles. But the other book is what is using the circle with plus and minus here. Initial is final. Okay, what this one here means, initial is final. Maybe it happens to you. You walk in the hallway and by accident you press one of the buttons on the vending machine and you get something back. Did you drop any coin? No. So in the final automata, something what is going to happen here. Without dropping anything, initial state is what is going to produce output. So this is the case where lambda is what is a word in the language of the machine. If initial state is also final state, means lambda is a word in the language of that machine. Okay, and if you compare it with the actual vending machine, that is the case. You don't drop any coin in the machine. But as soon as you press one of those buttons here, you get something back. But someone for sure drop a coin before you. So in that case, we say lambda is what is a word in the language of that machine here. If it is a null state, both machine are what are using exactly the same notations here. So because I had problem to draw something like this one here, you can see this one here, I had it, but it doesn't show it here. This one here, I had it, but it doesn't show here. It is hard to draw. We are going to use these notations throughout the semester. Every time we talk about finite automata, we are what? We're going to use notation like this one here. A circle with minus means initial state. A circle with a plus means what? A final state. A circle with no plus and no minus is a null state here. It is possible initial state to be a final state. You mark it with plus and minus. Okay, so these are the notations we are using throughout the semester.
Could you please
Good?
repeat one more time?
I can get it.
Could you please repeat one more time? Which one is in?
Okay, one more time. These are the notations in one of those books. These are notations in the other book here. So I prefer to use these notations throughout this semester.
Oh, okay.
Okay, so now let's have more fun. Okay. I clean up this one, everything. Okay, so now let's see how you can use those information so far here. If your FA look like this one here, if your FA look like this one here, I'm using what? Capital letters to name the states. Means what? I'm not going to use the angle brackets anymore. Yes? Okay. What this one machine, what is the language of this machine? Means what can I drop from initial state to end up at a final state here? So the only thing I can drop in this machine is what is A. If I drop A in the machine, I end up at the final state here. Therefore, the language of this machine is what is A. The language of this machine is what is A, because A is the only coin. A is the only input I can use to take me from initial state to a final state. Therefore, the language is what is A. Got it? What is the grammar of this machine here? From state A, if I drop A, I end up at a state what? B. From a state A, if I drop A, I end up at a state B here. And then what? B is final. So B is in form of lambda. Therefore, the grammar of this machine is A at a state A, drop A to enter B. And then what? B is final state, so this one here. So if I have a grammar like this, if I have a grammar like this one here, A is in form of drop A to enter B. And B is what? Is in form of lambda here. If the grammar is this one here, how do you draw the machine? Remember, grammar is representing what? The machine here. Okay, how many states the machine has? 1, 2. So this one here is state A, and this one here is what is the state B. Okay, A is in form of this is the first grammar, means what? A is initial state here. And what this grammar tells you from a state A, if input is A, go to a state B. And then what this grammar tells you, B is final state, so B is what is final state here. So if I have a grammar, I can go to the machine. If I have the machine, I can write what? I can find the language and I can find the grammar here. Got it? Okay, now look at this one here. My machine is what is this? It has two states, A and B. From initial, if I put A, I enter here. At a state B, no matter how many coin B I drop, I end up at what? At the same state here. What is the language of this machine? Okay, who wants to help me? Okay, L is equal to. If I drop 1A, I end up at what? At state B. I can get something back from the machine. So A, right? If I drop 1A and then I get to here, I don't want to stop. I drop 1 coin B. So AB is still I what? At the final state here. And then what? 1A, and then what? If I drop 2 B's, is still what? I am at a final state here, and so on. So what does it mean? Means all these words, they have A in common. Where do they have A in common? On the left-hand side. I factor by A. If I factor by A, so what do I get first?
Lambda.
Lambda. What do I get from this one here? B. What do I get from this one here? B squared. And what? And so on here. So what is the language of this machine? Is A.
B star.
And what are all of these? B
Star.
star. Okay, so this loop, this is a loop here. And that loop is what is always create a star here. So the machine is initial state 1A, get to here, a stop, or you can drop as many B's as you want. What is the language? It is 1A, you get to here, but here I can drop as many B's as one. 0B, 1B, 2B, 3B's. The language of this one here is what is this. Okay, what is the grammar of this one here? From a state A, if input is A, you get to B. A, input A, you get to B. From a state B, if input is B, you go back to B, and then B is what? B is final. So now, if I have the grammar, A is in form of A, B, and then B is in form of B, B, and then B is in form of lambda. Okay, I have the grammar. Can I construct the machine? I have to, because grammar representing what? The machine. Okay, how many states the machine has? Look at the left-hand side. 2 states, A and B. So this is state A, and this one here, what is state B. A is what is the first grammar. So A is what initial state here. Because of this, B is what is final state here. What the first grammar tells you, start from A, drop A, you end up at what? At B. And what is this one here? Start at B. If you drop B, you get back to B. If you drop B, you get back to B here. So we use capital letters to name states. We use lowercase letters, what? As input. As input here. Okay, now let's have more fun here. What is the story of this machine?
Professor, in the second example, the summation is equal to A comma B.
Oh, this one here?
The second one in the language,
Yeah,
find the language. First line.
Which one?
The first line, summation is equal to.
This one here?
No. In the second example, summation is equal to A comma B.
Oh no, this is the alphabet.
Yeah, alphabet.
Yeah, the alphabet is see the input, A or B. What is the alphabet of this one here is just A.
So, but the second one and fourth one are the same. The language is the same, A comma B. I'm
No,
little
not
bit
the
confused
same.
with that.
This is initial, and then A, and then a stop, and then B. Okay? A or B. Is this the language of this machine? See, if I start at A, at initial state, if I drop A, I get to final state. So this is okay. Is this one here a word in the language? I start at here. Can I drop B? No, it's not defined. So B is not in the language.
Yeah.
So it's not AB. Okay, but if I have L is A and then AB. Okay, A is good. AB is what is good. But I can have more of those. I can have A and then what, get to here, go through this loop twice. Or I can get A, get to here, and then what, go through that loop 3 times, and so on. So now I can see what the pattern. All these words, they have A in common on the left-hand side. If I factor, what do I get? Lambda. What do I get from this one here? B.
B.
What do I get from this one here? B squared and the power, all powers of B. So it is A.
B
What
star.
is the name of this language?
B star.
B star here. Got it?
Yes, Professor. Thank you.
Okay, so you see, is A word in this language, in this machine? Yes. B star is lambda, A is what? A is a word. Is B a word in this language? Is B a word in this language? No, any word in this language must have what? A first. And that's what the machine doesn't accept B. Okay, so later on you can see that a language, if you have a machine, you can find the language, you can find the grammar. If you have the language, you should be able to find the machine and grammar. If you have a grammar, you should be able to find the machine and what, and the language here. So the FA, the language, and what, and the grammar. If you have this, you can find this, and then this one here, and then this one here, and then what? This one here. So if you have one, you can find the other two. Okay, if you have one of them, you can find the other two here. Okay, now let's go to this guy here in Mickey Mouse.
If we have a language, we can find grammar and machine.
I'll go through all those examples. Hold on, please. Okay, if you have a machine like this one here, A, and then what, and then B. Okay, the name of the state is what is A. What is the language of this machine here? The first person give me the answer, or not, but I have the answer. I have the answer. So L is equal to. Initial state is final state. Means what? I don't need to drop anything in the machine. Therefore, lambda is what? Is a word in the language. Yes? I can go through how many words of length 1 we have. Either I can go through this loop once, or I can go through this loop here once. So these are the words of length 1. Correct? Yes?
Yes.
You're not firm. Yes or
Yes.
no?
Yes, yes, we are.
Yes, very good. Okay, how many words of length 2 we have?
A, B,
I can
B.
go through the loop A twice. I can go through the loop B twice. Or
A, B, A, B,
A, B, very good. Or
B, A.
A. Okay, and so on here. So what do I have? I have lambda, I have A or B, I have all words of length 2, A or B, to what, to second power. And dot, 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 which is
A or B star.
A or B star. So, and it makes sense. I can go through this loop only. I can go through this loop only. It means all powers of A, all powers of B. I can switch back and forth. So any combination of A's and B's are what are also in the language here. And that is what? A or B star here. Okay, now look at this one here. I can draw this one here like this. I can draw this one here like this one here. Initial and final. Instead of two loops, I can have what? Only one loop. Label this one here A or what? Or B. Means every time you go to this loop, up to you. You can choose A or you can choose what? You can choose B. Got it?
Yes, Professor.
This is what? A or B star. In general, if I have one loop, for example, alpha, what is the language? Is alpha star. If I have two loops here, alpha and then what? Beta. This is the same as plus or minus, and then one loop, either alpha or what? Or beta here. So the language is alpha or beta star. If I have three loops, plus or minus alpha, and then beta, and then what? Gamma. This is the same as plus or minus alpha or beta or gamma. What is the language? Alpha or beta or gamma, the whole thing is star. Yes?
Yes.
Perfect. Perfect. Okay, now okay, more examples. I have a machine, what machine like this one here. There are two final states. Let me draw it bigger and talk about it here. This is initial. And then A, this one here, 1B, we get to here, we stop. Or one more A, we get to here, a stop. Or we can have what as many B's as we want. Okay, what is the language of this one here? L is equal to, we have two final states. We have two final states means what? There are two set of words in the language of this machine. One set of words, if you end up here, how can I end up here? Start with any number of A's. A loop, right? Still what I'm here. One more B, I get to here. So this is what? One set of words in the language of the machine. Or, okay, I want to get to here. Okay, how can I get to here? Don't forget about this guy. Any powers of A. 1B. Don't stop. 1A. And then what? Get
B
to
star.
here. Stop, or you can have as many B's what as you want here. So two final states means what? Two set of words here. But remember, to get to here, you have to go through all the loops to get to here. Don't say, okay, from here to here, I need B and A. No, you can have any A's, and then B, and then A to get to here. So don't forget about A star. And now if you want to simplify this one here, A star in common on the left-hand side. So from this, we get B. From this one here, we get B, A, and then B star here. Or we can say what? This one and this one here, they have A star B in common. See, they have B in common here. A star B,
Lambda.
lambda, and then or A
B star.
star. Good?
Good.
Perfect. I hope you are not tired yet.
I'm sorry. Can
Yes,
I
ma'am.
see the note one more time?
What is it?
Can I see the note one more time?
Okay. The same problem? Sure.
No,
Hold
I'm
on.
copying the note, and then I haven't finished it.
Oh, copy it. Then please print a note. Okay, this, I mean, today is the first day here. Starting next week, print the notes. And then when I lecture, you can add what all the extra examples I do next to the notes here. Okay. So the problem was this one here, initial and then a loop, and then B, you get to here, you stop, and then you drop A, you get to here, you stop, or you can what? Waste your time and drop as many B's as you want and stop. What is the language of this one here? There are two final states. So the language consists of two set of words. One to end up here. How can I end up here? Drop as many A's as you want, and then one more B to get to here. How can I end up here? I have to start from here. To start from here, I can start with any number of A's. I can drop one B to get to here. Don't B, A star B, they have A star B in common. From this one here, you get lambda. From this one here, you get AB star. Good. Okay, now let's look at this one here. Let's start from here, initial. And then 1A, you drop to in the machine to get to here, a stop, and then what? Drop as many B's as you want. If your first coin is what is B, then you go to here, and then what? Either you stop, or you can drop as many C's as you want. What is the alphabet of this machine? I can drop A, B, or what, or C, A, B, or C here. See, the first example I use the vending machine is going to make everything here easy to understand. So all of these are what finite automata is vending machine here. Let's start at this one here. If you drop A, it takes you to this state. If you drop B, it takes you to this state here. If you get to here, you can drop as many B's as you want. If you get to here, you can drop what as many C's as you want here. Okay, who wants to help me to write the language? 1 and then what? 2. So 1 and then what? 2 here. How can I get to here?
A B star.
1A, as many B's as I want. 1A, as many B's as I want. How can I get to here?
B C star.
And as many C's as I want. Do they have anything in common? No.
No. Yes.
Okay, do you have fun?
Yes.
Okay, now let's go to this one here. Okay, this is initial and final. Okay, you can go through any number of C's. As soon as you drop A, you get to here, and what you can have as many B's as you want. And then what? If you drop a B, you get to here, and you stop. Okay, this is A, this is B, and this one here, what? C. How do you write a grammar for this one here? Start at B, initial state. If you drop C, you get back to what? Back to B. And start at B. If you drop A, you go to C. Start at B. If you drop B, you go to A. Correct? And then what? If you get to C, if you drop any B, you get back to C. Right? And then A is what? A is final. So A is lambda, B is final, B is lambda, and then C is final. So C is what is lambda. This is the grammar for this machine. The first grammar indicates what? The initial state here. So B is initial. You have to start at initial. Got it? Okay, now, all these three, the first three, they have what? B on the left-hand side here. So from B, if I drop C, I get back to B. Then you could use a pipe, or if you drop A, you can back to C, or if you drop B, you can go what? You can go to A here. So three grammars, you can write them in one line. At B, if you drop C, you go back to B. At B, if you drop A, you go to C. At B, if you drop B, you go to A. Got it? or at B what you can stop here. So then I don't need this one anymore. So this, and this one here summarized in this form. Okay.
So how drop B will go to A, the last step?
This one here, A goes to lambda. No, those stays the same. See,
No,
C
you
is lambda.
combine 3 to 1.
Oh, okay. Yeah, very good. So this one here, C is BA, or C is what is in form of lambda. I don't need this. Good, very good. Okay, now
Actually,
I want to.
my question is last line, the previous line.
I erased it. Sorry. How can I put it back? Redo. No, it doesn't do it. It doesn't do it. Okay, I want to find a language. So plus or minus, this is C, this is C, and then this one here is A, stop here, and then B, and then go to here, input is B, and then stop here. Okay, how many finalists I have? 1, 2, 3. So L is equal to 1 part, 2 part, and 3 parts here, right? Okay, what is this one here? From here, if I drop any A's, I get back to final. So what is the language?
C star.
It's supposed to be C, Professor.
A star.
It's supposed to be C, right?
Yeah, A star. Oh, sorry, C star.
Yeah.
C star. Okay, well, I want to go to this. So I start with what? With any number of C's, and then 1A go to here, and then what you can have as many B's as you want. Yes? And then go to here, start with any C's you want, and then 1B, you stop. Good? Perfect.
Could you please show one more time how you combine the first 3 to 1 statement?
No, okay, then I have C star here, C star here, C star here. I can factor by C star. And this is lambda, and then A, B star, and then what? And then B. Now, for the first homework problems, you don't have to simplify. If you want to do it, but you don't lose point if you don't simplify, because it's too early to be worry about simplification.
Professor, does the
Yes,
order or does the order matter? Like if I do C star and then C star B, and then I do C star A.
No,
B.
that's fine. That's fine. It's a collection.
Okay.
See, I have this basket. I have
Right.
apple. I have banana, and I have what? I have grapes. So the order doesn't matter.
Thank you, Professor.
The order doesn't matter. See, or is what is union. A union B union C is the same as B union A union C, right?
Right.
Okay, so yeah, don't worry about the order. Okay. So now, okay, you should be able to answer question like this one here. I give you a table. See, if you have one, you should be able to find the other two. So the FA is given. I want to find this, and I want to find this one here. The grammar is given. Find this, and then what? The language is given. Find this and find what? Find this one here. So if you have one, you should be able to find the other two. Okay. So given context-free grammar, find FA and find the language. So the grammar is what is this one here. If you look at the grammar, how many states we have? A, B, and what? And C. So this one here is A. This is A. And then this one here is B. And this one here is what is C. A is what? A is initial. From A, if input is A, back to A. From A, if input is B, go to B. Yes. When you get to B, if you have a B, back to what? Back to B. At B, if you get A, go to C. And then at B, you can stop. And then at C, if there is a C, back to C. Or at C, stop here. Okay, so if you have a grammar, to find the language is better what to find the FA first. From grammar to language is better what to find the FA first. That's the easiest way to find the language. Okay, who wants to help me? L is equal to how many parts? 1 and then 2. So this is part 1 and this is part 2. How can I get to here? Any powers of A and then what?
B.
1B. I'm here.
That B star.
I have what as many B's as I want and I end up at here. Okay, part 2, get to here. Any powers of A. 1B. Get to
B
here.
star.
Have
B star.
as many B's as you want, but
A
don't
and
stop.
And then
1A,
1A,
you are
B
here,
star.
and
then
then
C
what?
star.
As many C's as you want. You want to simplify, this part is the same as this part here. So A star, B, B star, and then lambda or A,
C star.
C star. A, C star. Okay, so these are the same thing. A grammar is given, find the FA and find the language. The grammar is given, find the FA and then find the language. You want to see more examples or this is good enough for this part?
I think it's good enough for the grammar part.
One more?
Or no, I think it's good enough for the given
Okay.
grammar. So I think we can move on to the given
Okay,
language.
move on. Now the language is given, find the FA and find the grammar here. Okay, very easy to do it. Okay, L is equal to A star or B star, right? Okay, start with, and I see I don't know the number of states yet. I don't know the number of states yet. So this is what lambda is, what is in the language. So initial state is final state here, right? Okay, only powers of A or only powers of B, no combination of A's and B's. So is this the answer?
No.
No, because I can get AB, I can get BA, but I don't have AB, BA, right? So that is not good. That is not good. Okay, so if I drop A, I can go to here, that is 1A, or I can have what? I can have more A's here, right?
Yes.
1A or more A's. And then what? Do the same thing for this one here. 1B, I get to here, stop, or I can have what? As many B's as I want. So now this is what FA for this language. Now it's very easy what to find the grammar here. Okay, if I have a loop A, I call this one here what? I call this one here state A. I have a loop B, I call this one here B, and then this one here, for example, X. Or any name you want to use, that's fine. So from a state X, if input is A, go to what? Go to A. If input is B, go to B, or stop at X here, lambda. At the state A, if input is A, back to A, or stop. At the state B, input B, back to what? Back to B, or stop here. Language is given, find context, find FA, and then find the grammar. Language is given, find FA, and then find the grammar. But if they ask you to Then what? Make sure to do this one here first. This is the language, find the grammar. If I'm smart, then I do this one here first before I go to, because from here to here is not easy. From here to here is not easy. Later on you can do it, but not now. So it's better to, from language, go to FA, and then from FA to what? To grammar. Got it? So I have what? I have more examples here. The language is given. Okay, let's look at any question on this. No? Okay. The next example, L is equal to A, B star, and then C, and then A or B star here. Okay, let's find grammar for this one here. Okay, first I find what? FA. So start from here. Is initial, final. See, lambda is not, because see, any word in this language must have A and must have a C. So lambda is not here. Means initial is not final. Right? Okay, 1A. 1A, I get to here. Can I stop?
No.
Not yet. I have to stop when I get to here. So here, if when I get to here, I can have what as many B's as I want. But still I cannot stop because I don't have word A, B stop. I don't have this one here. It's still what? I have to drop C. If I drop C, I get to this state here. And now what? This is lambda, I can stop here. What? I can have what? Any combination of A's and B's here. So any combination of A's and B's here. Got it?
Yeah.
Okay, I call this one here. I call this one here B. I call this one here X, and I call this one here, for example, A. Okay, from A, or you can name it anything you want. If input is A, go to what? Go to B. And that's the only thing I have. When I get to B, input B, back to what? Back to B. Input C, go to what? Go to X. And when you get to X, input A, back to X, input B, back to X, or stop. Yes? Okay, so this is the language is given. Find FA to find the context free, to find the grammar.
So what's the sign for the middle one?
The middle one
Null
is null
state.
state. Nothing happens here. It's a null state here. So if I get to B, if I get to here, I don't stop. See, it's not a final state. So the language has only one piece. It is only one final state. Got it?
So then what's the first line means? A and then drop A to B.
Could you speak louder? I can hear you.
So what's the first line mean? Like A to B.
A and B, you get to here. You don't get anything back from the machine.
Oh.
If you drop A and you drop B, you are here. You don't get anything back. But if I drop A and no B, means I don't go through this loop. If I drop A and C, I can get something back from the machine. And see, the word AC, this is lambda. This is lambda, the word AC in the language. The word AC is in the language. Means if I drop A, if I drop C, I end up at a final state. Okay, is B in this language? No, any word in this one here must start with what? With A. Any word in this one here must start with what? With A. So B is not in this line. Okay, and what is the last one? The grammar is given. find what? Find the language. That is, we need to use it next time here. Okay, so the grammar is what is given. Find what? Find the language. Then from the grammar, go to a machine, and then from the machine, find what? Find the language. Okay, so something like this one here is the same type of problem. The language is given, find FA, find the grammar. The grammar is given. Sorry, the machine is given. Find the grammar, find what? Find the language. The grammar is given, find this, and find what? Find this one here. And I did a lot of examples for each case here. So this is what the summary of everything I did before here. The language is given, find FA, find the grammar. The FA is given, find the language, find grammar here. The grammar is given, find FA, and then the language. Okay, and I did it here. For the language is given, what is the content of this box one here? The content of box one is what? A, B, star. So put A and then any more B's, and then put drop B and as many A's as you want, which is this one here. So the machine representing this language is what is this one here. Use this to write the grammar here. So this is the content of box 2. And the same thing for this one here. You have the machine, up to you. You can find the language, you can find the grammar, or you can find the grammar and find the language here. So this one here doesn't matter. If the language is given, find FA before you find the grammar. If the grammar is given, find FA before what? Before you find the language here. Okay, and this is the content of the box 3. The machine is given, what is the language? The machine has 1 and then 2 what? 2 final states. So the language consists of 2 sets of words. The language consists of 2 sets of words. Okay, go from here to here. I need what? Only 1 A. I need only 1 A. And then what? Go from here to here. Go from here to here. There are 2 ways to go from here to here. One is what? Only 1 B, and then more stars, more A's, 1 B and more A's. Or I can go from here to here this way. 1 A, 1 B, 1 A, 1 B, and then what? As many A's as you want. So even though we have 2 final states here, but the language has what 1, 2, 3 parts, because to this final state, there is only 1 way to do it, and that was this. To get to this one here, there are 2 ways to do it. So either this or this one here. That's why I have this piece and this piece here. Okay, so keep those in mind and have fun when you do. Okay, and then this, I'll be done in a few seconds here. Sometimes it's nice to simplify your machine to find the language. If you have 2 loops, you can change it to 1 loop. If you have 2 arrows, 2 edges, you can have 1 and then A or B, A or B. If you have something like this one here, 1B. See, this one here is a null state here. So any number of A's and then C. You can remove this one here. Any B, any A's, and then 1 C you can get to here. And if you from here, either you go to this or you go to this one here. So B, any number of A's and C. B, any number of A's and C you get to here. B, any number of A's and D, you can get what you can get to here. I eliminated what? This one here. Okay. Sorry, this one here is computer science 323. Maybe that's why I was not able to change it here. 323, assignment number 1. Okay, these are what? These are the questions. These are the languages. These are the questions. Mark here true or what or false. Mark or circle your true or what or false. Circle your answer, true or false. This one here, the machine, the language is given. Find the FA, find the context-free grammar. The machine is given, find the language, find the context-free grammar. The grammar is given, find these two. And then find the language of this grammar. So first construct the machine and then find the language. If the grammar is this one here, find the machine and then the language. Okay, here I have the first programming assignment. Okay, do you know postfix from 131? Some instructors, they talk about it, some they don't talk about it here, but for this course, you have to know them. You have to know them here. Do you know prefix and postfix? I can hear you, yes or no? Okay, if you don't.
No.
No.
Okay. Yeah, that's okay. That's okay. That is something I was going to talk about it at the beginning of the class, but the time is over. So don't do this problem. Don't do this problem here. Okay, just answer those questions on paper. And so you do this, that the first part, you do it as by your team. And then the last one is what is the quiz. This one here is the quiz. You do it by yourself and you turn it in before the Wednesday class next week. So the homework, I want to get it with 2 names. Okay, the quiz, only you do it by yourself. And drop everything in convex.
And Professor, can we choose our partners?
Can you use, yeah, you can use your partner, anyone you want it. So starting, when you turn in your paper next week, then I know who is your partner. Okay. So when I grade your paper, I give the same grade for both of you. And I hope it's not hard for you to find your partner, because this is your last class, and for sure you have had a lot of classmates so far. Do you want me to, okay, let me show the name of all the students, and then look at this one here to see if anyone look familiar to you. Okay, this is the name of all the students in the class. Okay, you can be my partner. So look at all these names. And then if you are done, I show you the rest of the names. Any questions? Okay, that's all for tonight. So no programming this week. Next week, I talk about the prefix and postfix, and then I lecture more. Okay, if you really want to have this course, because if my class changed to normal, then we have to meet in the class in which the size is only 34 students. So because there are 3 people in the waiting list, then your chance to register for this course is not high. My recommendation and the partner recommendation is please check other sections there are 7 sections of this course. And a lot of those sections are what are not full. So please don't wait because a lot of students, they want to take this course. So take care of it as soon as possible. And if you want to register, either go and register directly because the section is open. And then, so this week still you can do it by yourself.
Professor, one question. So do we, after completing the assignment, do we submit it on Canvas?
Yes, please.
Okay, okay, sure. Thank you so much.
The assignment.
The homework and the quiz, please turn them in before 7 p.m. on Wednesday next week.
Understood. Thank you so much, Professor.
Anything
Professor,
else?
what's your office hour?
The homework and the quiz.
Office hour.
Oh, office hours. I don't know yet. So because I don't have office in the school yet, they haven't assigned me office. And today was the afternoon. I learned from department that the class has changed to online. So maybe how about Tuesday? Do you want? I mean, is it okay if I have office hour on Tuesday night?
Should we make an appointment?
Thursday? No.
You
It's
mean-
better to have office hour before what? Before the lecture. So Tuesday night, 7 o'clock.
So Professor, do we join the same link?
You don't have to join. If you have any questions, please come to class on Tuesday at 7 o'clock, from 7 to 8.